Hello and welcome to Pre-Algebra Lesson 39. In this video, we're going to learn about decimal fractions. All right, so our lesson objectives for today would be to learn how to change a decimal fraction into a decimal. And then also, we want to learn how to change a decimal into a decimal fraction. So basically, we're going to go back and forth between a decimal and a decimal fraction. So before we get started, I want you to think about the very first lesson where we started talking about fractions. What I told you there is that although some of you didn't have any experience with fractions in your math class, you had seen fractions in your everyday life. Every time you and a group of friends get together and you split something up, so if you got together and you split up a pizza, or you split up a cookie, or you split up an apple, or whatever it was, you gained some experience with fractions even though you didn't know it. It's going to be the same thing for decimals, right? So although you might not have seen decimals yet in your math class, you have worked with them in everyday life. One example is that you are absolutely bombarded with decimals every time you go shopping for anything. So let's kind of get started with our lesson with a basic definition. So when we start talking about decimals, kind of the introduction to that would be the decimal fraction. So a decimal fraction is a fraction whose denominator is a power of 10. Let me reread that. A decimal fraction is a fraction whose denominator is a power of 10. So what do we mean by that? The denominator is a power of 10. It means you can take the denominator and rewrite it as 10 raised to a whole number that is 1 or larger. So here are some examples of some decimal fractions. So we have 5/10 here, and you can see that this 10, I could rewrite that as 10 to the power of 1. Here I have 3/100. I can rewrite 100 as 10 to the power of 2. Here we have 700,000ths, and I can rewrite this 100,000 in the denominator as 10 to the 1, 2, 3, 4, 5. There's 5 zeros here, so 10 to the 5th power. So in each case, we have a decimal fraction because the denominator is a power of 10. And again, more specifically, that means that 10 is raised to some whole number that is 1 or larger. So to kind of get our feet wet with decimals, let's kind of run through a typical scenario. So let's suppose you go to the grocery store and encounter a can of tuna priced per can at $1.38. So this is typically how you're going to see decimals. Now, let me just skip the dollar sign real quick and just write 1.38. Now, the first thing I want to draw your attention to, you might not know that this is called a decimal point. This is a decimal point. Now, what's to the left of the decimal point, this 1, this is just a whole number. This is what we've been working with forever. So I'm just going to put that this is a whole amount. A whole amount. And in terms of money, I just have $1 there. Now, this part that occurs after the decimal point, or to the right of the decimal point, is part of a whole. It's part of a whole. Again, we've already seen this with fractions. And if I was to think about $1.38 kind of using fractions, well, okay, $1 is kind of a whole amount. It's a $1 bill. Just think about 38 cents for a minute and how you could relate that in fractional terms. Well, if I had everything in pennies, let's say, it takes 100 pennies to make $1 or one whole amount. So if I only have 38 pennies out of the 100 pennies that are needed, really what I have is I have 38 out of 100, or 38 parts out of the 100 needed to make a whole amount. Remember, when we work with fractions, our denominator is the whole amount split up into equal parts. So this is me taking $1 and just splitting it up into equal parts of 100. That's what would happen if I got $1 in pennies. And then if I only have 38 of those pennies, well, then I have 38 parts out of 100, right? So this 0.38 is the same thing as 38 over 100. So really, we can kind of see already that we can go back and forth and write 1.38 as 1 38/100ths, right? These would actually be the same. Here you have a whole amount, and then you have part of a whole. Here with your mixed number, you have the same thing. You have a whole amount, or your whole number part, And then you have your fractional amount, your part of a whole. You have 38 parts out of 100. So kind of the first thing we're going to learn is how to change to a decimal. So if you're starting out with the decimal fraction, the first thing you're going to do is count the number of zeros in the denominator, and then you're going to delete the denominator. So if I had something like, let's say 56 over 100, I would count 2 zeros. So 2 zeros. And once I have that information, I can just delete the denominator. Right? I'm just going to have the number 56 now. And I'm going to have 56, and I'm going to know that I have 2 zeros for that denominator. Then the next thing in the numerator, which is the number 56 that we have, move the decimal point to the left by the number of zeros we counted in the denominator. So again, we had 2 zeros. But some of you at this point might be saying, how do I move the decimal point to the left? I don't know where it is. If you have a whole amount, you can always write a decimal point after the rightmost digit. So I can write 56 as 56 and then a decimal point. And another thing I'm going to teach you is that after this decimal point, you can put as many zeros as you want. You might see some prices in stores look like this. $56, you might see a decimal point with 2 zeros at the end. Or you might see $38 like this. Or $27 like this. After that decimal point, you can put as many zeros as you want, and you're not changing the value of the number. This is still 56, or in this case, since I have a dollar sign, it's still $56. So with that being said, we're going to move our decimal point to the left by the number of zeros we counted in the denominator. We counted 2 zeros, so I'm going to the left 2 places. So we would end up with 0.56. Now another practice that you might get into when you start working with decimals is if you have a decimal point and you don't have a whole number amount, you'll probably put a 0 out in front. This 0 does not change the value of the number. It's just kind of used for clarity, right? So that people when they're eyeballing it will say, okay, oh, I have a 0 first. Well, that's a little weird. So that draws their attention to the fact that there's a decimal point so that they don't miss it, right? You don't want to mistake 0.56 or 56. All right, let's look at the first one here. So we have 40 over 100. So again, the first thing I'm going to do is count the number of zeros in the denominator. Again, I have a situation where I have 2. So I have 2 zeros. And then I'm going to delete the denominator. So I don't actually have to do that. I'm just going to write over here, I'm just going to write the numerator without the denominator. So I'm just going to write 40. Then the next step is to move the decimal point by the number of zeros that we counted in the denominator. Again, we counted 2 zeros. So again, I can put my decimal point here after the final digit of 40. And I'm going to move it 2 places to the left. And that's going to give me 0.40. Now I want to draw your attention to something. If I have a 0 right here, it's the same thing as if I erased it and had 0.4. Again, after you have a decimal point, once you have your final non-zero digit, you can add as many zeros as you want. So 0.4 is the same as 0.40000000. Where people get confused is, let's say you have a bunch of zeros, but then you have a non-zero digit involved. Let's say you have a 9 at the end. This is different than 0.4. Those are not the same. If I have all zeros, then it's the same. But if I have something that's not zero that kind of is at the end or even in between, let's say I had a 9 here and then a bunch of zeros, that's still not 0.4, right? You can't have it interrupted in any way. It has to be 0 all the way down. So having said that, we can rewrite this answer as just 0.4. All right, let's take a look at another one. And I'm going to kind of shorten this up a little bit. And one of the things I want you to realize here, and you're going to use this later on in math, when you divide by 10 or some power of 10, and when I say a power of 10, I mean 10 raised to a whole number that's 1 or larger, you move your decimal point 1 place to the left for every 0 in that power of 10. So just forget about your procedure for a second and just say, okay, I have 7 divided by 10. So I'm going to write 7 and I'm going to write my decimal point. I have 1 0 in this power of 10, so that means I'm moving my decimal point 1 place to the left, and I'll end up with 0.7 as my answer. Again, you can still use that procedure. That's kind of a procedure you're going to get in a book. Count the number of zeros you have in the denominator. You have 1 0. Delete the denominator. So I would have just wrote this as 7. and then move the decimal point one place to the left for every 0 that you count in the denominator. So it goes over here. And again, you end up with 0.7. All right, let's look at 85 over 10,000. So again, I'm going to use that kind of shortcut because when we find a shortcut in math, we kind of want to use it. So I'm just going to write 85, and then I'm dividing by 10,000. So this is a power of 10 with 1, 2, 3, 4 zeros. So basically, all I need to do is move my decimal point 4 places to the left. So I put a decimal point after the final digit in 85, and I go 1, 2, and then I see that, what do I do here? I don't have any more places. When that happens, I can put zeros in. So I can put a 0 in here, and here, and then 3, and then 4, and I'm able to complete that. So now I'm going to end up with 0.0085 as my answer. What about 5 and 35 over 1,000? Well, what happens is if you have a mixed number and you're doing this, just take the whole number part and go ahead and just write that. Then we'll follow that with 35 over 1,000 expressed as a decimal. So to do that, I have 35, and basically I'm dividing it by 1,000. So I have 1, 2, 3 zeros in this power of 10, right? 1,000 is basically 10 to the third power. So all I need to do is move the decimal point 1, 2, put a 0 in, 3 places to the left. I'd have 0.035. So if I have 5 and 35 thousandths, then basically I have 5.035. The decimal point with 0.35 after it is 35 thousandths. And then the 5 is just the same. Okay, so now we're going to go backwards, right? We're just going to reverse what we just did. So we're going to be going from a decimal to a decimal fraction. Now, one of the things I want to tell you right away, we're not going to be simplifying here. And the reason is if you want to report something as a decimal fraction, again, the denominator has to be specific. It has to be a power of 10, right? Meaning that it's able to be expressed as 10 raised to a whole number that is 1 or larger. So the first thing we're going to do is write any whole number if you have one. Then you're just going to count the number of decimal places. And basically when we say count the number of decimal places, we're saying that we're counting the number of digits that occur after the decimal point. And these are only digits that are going to add value to the number. So for example, if I have the number 0.38700, I don't have 5 decimal places here. Some people would say, okay, I have 5 decimal places. I don't. I only have 3. These two don't add any value to the number. This is the same thing as 0.387. So I would count 3 decimal places here. So once you know that, you take that decimal part. So that's the part that occurs after the decimal point, and you put it over a denominator that begins with a 1 and is followed by the same number of zeros as decimal places. So for 0.387, basically you write 387 in your numerator, you write a 1 in the denominator, and you follow it by 3 zeros. Right, and that's because we had 3 decimal places here. If I had, let's say, made the mistake of including these 2 zeros here, I would end up putting 5 zeros down here, and I would get an incorrect answer. This is wrong, right? Because these zeros didn't add any value, so I don't have a denominator of 100,000. I would take these away and then just say, okay, I have 3 decimal places, so I'm going to have 1, 2, 3 zeros. This is 387 over 1,000. All right, so we're going to start out with 0.05. And again, this 0 out here to the left of the decimal, that's just for clarity, right? We don't need to do anything with that. So the first thing I'm going to do is I'm going to count the number of decimal places that I have. So after the decimal point, I'm looking to see what I have. I have a 0 and then a 5. So I have 2 decimal places. 2 decimal places. And remember, this 0 matters because it's followed by a 5. If I have 3.00, these zeros do not add any value. But the second I follow that 0 with a non-zero digit, let's say 3.03, this 0 does matter now. So because I have, again, a 5 that follows the 0, this 0 does matter. So we have 2 decimal places. Now, the next thing we want to do is write our decimal part So that's the part that occurs after the decimal. In this case, that's a 0.5. And the numerator of the fraction, and we're going to put the denominator of the fraction as a 1, followed by a 0 for every decimal place we have. So we had 2 decimal places, so you get 2 zeros. Now a couple things here. I don't need to have this 0 in front of the 5 because that adds no value to the number. When you're working with whole numbers, I can always put zeros to the left. So I can put as many zeros to the left. This is still 5. Kind of similar to when I'm working with decimals. I put a decimal point. I can put as many zeros here. It's still 5. What I can't do, if I have a whole number, I can't just start adding zeros in. This number is now 5,000. It's not 5 anymore. So the last thing I'm going to draw your attention to is, a lot of you will say, okay, well, you can simplify this fraction. It's 1 over 20. Well, yeah, we can, but it's no longer going to be a decimal fraction, right? It's just a regular fraction at that point. And a decimal fraction has a definition where the denominator, again, is a power of 10. So we're going to leave it as 5 over 100. And that's exactly what you're going to do if your teacher says that she wants a decimal fraction, right? Do not simplify it. All right, for the next one, we have 21.34. And again, if we have a whole number part like we have here, we're going to write that first. Now, for the fraction part, I'm going to kind of make this simple. Take the part that occurs after your decimal point, just write it as the numerator. So 34 goes in the numerator. Put your fraction bar, then put a 1, and then you can kind of just mentally look at this and say, okay, I have 1, 2 decimal places, so I know I have 2 zeros. So we get 21 and 34 hundredths as our answer. And it's really, really that simple. You can go through the procedure each time, but after you work 5 or 6 problems, you can kind of just do a lot of this stuff mentally. What about 0.3975? Well, I'm just going to take the decimal part, again, the part that occurs after the decimal point, write that in my numerator, so 3975, or 3,975. For my denominator, I'm going to put a 1, and I'm going to follow that up with a 0 for every decimal place I have. Well, for decimal places, I have 1, 2, 3, 4. So this is going to get 1, 2, 3, 4 zeros, or 10,000 for the denominator. So we get 3,975 over 10,000. Okay, for the last one, we have 4.279. And again, I'm just going to write this whole number here to start. For the fraction part, just take this, your part that occurs after the decimal point, put that in the numerator. I got my fraction bar. I'm going to put a 1 in the denominator. And again, I'm going to follow that up with a 0 for every decimal place that I have. So I have 1, 2, 3 of those guys. So I'm going to put 1, 2, 3 zeros here. And I end up with 4 and 279 over 1,000. Or I could say 4 and 279 thousandths. Hello and welcome to Pre-Algebra Lesson 40. In this video, we're going to learn about comparing and rounding decimals. So the lesson objectives for today, we want to learn the place values to the right of the decimal point. We also want to learn how to compare 2 or more decimals and determine their rank. And then finally, we want to learn how to round decimals. So in our last lesson, we introduced decimal fractions. And then we learned how to go back and forth between decimal fractions and a number that has a decimal point. So in this lesson, we'll dig a little bit deeper into decimals before we move on and start doing some operations with decimals. So the first thing I want to show you is an expanded place value chart. So kind of in our very first lesson where we learned about place value, we saw everything to the left of the decimal point, right? We have the ones, the tens, the hundreds, the thousands. As we move to the left, remember each place, if I think about the ones place as starting with a 1, every time I go to the left, I just multiply by 10 to get to that next place. So 1 times 10 gives me 10. Now I'm in the tens place. 10 times 10 gives me 100. Now I'm in the hundreds place. 100 times 10 gives me 1,000. Now I'm in the thousands place. And so on and so forth. That pattern would continue forever. Now that we have a decimal point involved, we have some place values that go to the right of the decimal point that we need to become familiar with. So the first thing immediately to the right of the decimal point is the tenths. And I got a lot of students that will guess that this place is called the oneths, right? Because this is the ones, the tens, the hundreds. And you have a similar pattern over here. It's just you don't have a oneths place, right? You start off with the tenths place. And I'm going to explain why in a second. So you have the tenths, the hundredths, the thousandths, then you have the 10 thousandths, the 100 thousandths, the millionths, the 10 millionths, the 100 millionths, the billionths, so on and so forth. And that continues in a usual way, right? After billionths, you'd have 10 billionths, 100 billionths, trillions, so on and so forth. Now, one of the things I want to show you right away, and just following this pattern that I just demonstrated, again, if you start off right here in the ones place, you have the number 1. I know that if I go to the left, I multiply by 10. So if I go this way, I multiply by 10, so times 10, and I get to the tens place. 1 times 10 is 10. Multiply times 10 again, go this way, get to 100. But if I was to go backwards and go to the right, really I could think about starting out at 100, dividing by 10 to get to 10. So to go this way, just think about dividing by 10. Another way to think about dividing by 10 is multiplying by 1/10, right? We learned about how division and multiplication are related. If I have 100 divided by 10, it's the same thing as if I said, what is 100 times 1/10, right? That's 100 divided by 10. Either way, it's the same thing. So what I'm going to show you here is that as you keep going to the right, so as we move from here to here, again, we're dividing by 10 or multiplying by 1/10, dividing by 10. So when we get to 1, let me just erase everything to this point. When we get to 1 and we pass over the decimal point, it's no different. So think about having 1 and multiplying by 1 over 10. Well, 1 times 1 over 10 is 1 over 10. So that's how we get to the tenths. Then if I multiply 1 over 10 times 1 over 10, I get to 1 over 100. And that's the hundredths place. Do it again. 1 over 100 times 1 over 10 is 1 over 1,000. That's the thousandths place. So as I'm going to the right, I'm multiplying by 1 over 10, or I'm dividing by 10. Again, either way you want to think about that. As I'm going to the left, I'm multiplying by 10. So if I take 1 over 1,000 and I multiply by 10, I'd get to 1 over 100. If I did that again, I'd get to 1 over 10. If I did that again, I'd get to 1, right? I'd pass over my decimal point. I'd be at 1, then 10, then 100, then 1,000, so on and so forth. So although you might not memorize the names right away, you can kind of put it together by just using this pattern. All right, so we're going to do a quick little exercise similar to when we worked with place values for whole numbers. We just want to state the place value for each digit. And let's start out with this number 0.175. And this 0 is just for clarity. I can put it in the ones place, but really there's no point. I'm just thinking about these numbers that occur after the decimal point. So let's fill in our place value chart. I have a 1 that will go in my tenths place. Let me kind of make that a little better. I have a 7 that's going to go in my hundredths place. And I have a 5 that's going to go in my thousandths place. And so remember, if you have 0.175, you could write this as a decimal fraction as 175 over, you have a 1 followed by 3 zeros, right? Because you have 3 decimal places. 1, 2, 3. And look at your bottom number. It's 1,000. Look at your rightmost digit of this number. It's in the thousandths place. So now, having said that, let's go ahead and label everything. So the 1 is going to be in the tenths place, the tenths place. And notice how everything after the decimal point has a THS, right? So you have 10 and then you put a THS, 100 and then you put a THS, 1,000 then a THS, so on and so forth. Then for 7, that's going to be in the hundredths place, hundredths. And then lastly, we have a 5 that's in the thousandths place, the thousandths place. All right, let's take a look at the next one. So we have 3.128. So the 3 is obviously in the ones place. And we have our decimal point. And then we have a 1 in the tenths place, a 2 in the hundredths place, and then an 8 in the thousandths place. All right, so let's label this. So 3 again is in the ones place. Of course, we know that position already. And the 1 is in the tenths, the tenths. The 2 is in the hundredths, hundredths. And then finally, the 8 is in the thousandths. The thousandths. All right, we have a really long number now. So we have 15.77201,958. So 15, here's your decimal point. You have 77201,958. Now, I want you to notice something. Again, I want to draw your attention to the fact that the rightmost digit here is in the 100 millionths place. So what that means is that, just thinking about pure numbers, forget about the this part of this number. If I have 100 million, it looks like this. So what that tells me is that my denominator here, if I was to write this part, just the part that occurs after the decimal point, as a fraction, the denominator would be 100 million. Right? I can take this off now. And then go ahead and put a fraction bar. The top part would be 77201,958, or the number 77,201,958. And again, if you follow your official procedure, you'll get the same answer. You would write this part right here as your numerator, and then you put a 1 followed by a 0 for every decimal place. We have 1, 2, 3, 4, 5, 6, 7, 8. And I have 1, 2, 3, 4, 5, 6, 7, 8 zeros. So that does match up. And of course, if we were to write this number, it does have a 15 out here as a whole number. So I would need to put a whole number part. Let me just kind of scoot this over a little bit. And then I could write 15 and 77,201,958 100 millionths. Okay, that's how you would say that. All right, but let's get back to what we're doing. And of course, we want to label the parts of the number. And I don't even know if I can fit this on the screen, but I'm going to try my best. So the 1 is in the tens place. This is the tens. The 5 is in the ones. The 7 is in the tenths. The tenths. This 7 up here is in the hundredths. Hundredths. Then we have a 2 that's going to be in the thousandths. Then my 0, let me draw an arrow over here. This is going to be in the 10 hyphen thousandths. And then my next number, which is this 1 here, that is going to be in the 100 hyphen thousandths. Then I have this 9 that's going to be the millionths. Then I have the 5. The 5 is going to be in the 10. Put a hyphen and then millionths. And then finally I have this 8, and that 8 is going to be in the 100. The 100 hyphen millionths. Millionths. So if you're already really good with working with place value for whole numbers, learning this will be really quite easy because everything is very similar. It's just a simple fact that at the end, you put a THS. You just put a THS. So you're going in a familiar way. If you can just remember that as you move to the right, you are basically multiplying by 1/10 or dividing by 10. You can go through and say, okay, if I have something in the tenths place, you can think about just 1 over 10. To figure out what the next place over is, just multiply by 1 over 10, and you'd end up with 1 over 100. So you could say, okay, I'm in the hundredths place now. All right, so the next topic we're going to talk about is something that students kind of struggle with. So we want to know, how can we compare the size of 2 or more decimals? So we're going to kind of think about how to do this through a practice exercise. We want to replace each question mark with the less than or greater than symbol. And for the first problem we're going to look at, we have 0.285 question mark 0.287. So kind of you're looking at these two numbers, and it's not completely obvious right away which one is bigger. It's not like if we looked at 13 and let's say 5. I know 13 is bigger than 5 right away. For these two, you might struggle a little bit. So what I want you to do is just stack the numbers on top of each other. So you have 0.285 and 0.287. And just line everything up by place value. So this decimal point is going to line up with this decimal point. you have the tenths that are in line, the hundredths, the thousandths, and if you had more digits, it'd be so on and so forth. Now what I'm going to do is I'm going to start at the very left of each number, and I'm going to compare digits that have the same place value. So these zeros are irrelevant. I just kind of move on. I'm going to look at this 2 and this 2. Now those numbers are the exact same, so I'm just going to move to the right. I have an 8 and an 8. Those numbers are the same, so I'm going to move to the right. Now I have something different. I have a 5 and I have a 7. Now we all know that 7 is greater than 5, so that tells me that the number that has the 7 is the bigger number. So basically what you're doing is you're just moving to the right until you find corresponding digits that are different. The digit that's larger is going to belong to the bigger number. So for this relationship here, the number 0.287 is bigger, so I would put a less than sign in here, right, to replace that question mark. Let's go ahead and officially do that. We'll put that 0.285 is less than or smaller than 0.287. And again, that's because this 5 here, that's in the thousandths place, is smaller than this 7 that's in the thousandths place for this number. But again, up to that point, they look identical. Let's look at another one. We have 12.9251. We have a question mark and then 12.9051. So again, these numbers look kind of similar. So stack them on top of each other. So we'll have 12.9251 and 12.9051. And when you have some whole number parts involved, you have to line those up as well. The key here is you want to think about lining up the decimal point. When you do that, everything else is going to take care of itself, right? I have the tens places lined up, the ones, the tenths, the hundredths, the thousandths, the 10,000ths, and again, if I had more digits, it would go so on and so forth. All right, so we're going to start all the way at the left. And one thing you have to make sure of is that these numbers have the same number of digits. So if I had something like 112.9051 and 12.9251, obviously this one's bigger, right? Because it has another digit to the left. But that's not the case here. We have 12 and we have 12. So that part is the same. So we're going to move on past this decimal. We have 9 and 9, and then we have 2 and 0. So once I see something that's different, again, whichever is the larger digit belongs to the larger number. So this number is going to be bigger because 2 is greater than 0, right? And those numbers are in the same position. So that tells me that 12.9251 is going to be greater than 12.9051. And again, the reason for that is everything is identical until we get to this 2. This 2 that's in the hundredths place is bigger than this 0 that's in the hundredths place for that number. For the next one, we have 0.00535051, question mark 0.005000. Now, one thing you might notice right away, remember in the last lesson I taught you that when you have a decimal point, after your final non-zero digit, the zeros after it do not add any value. I can delete these zeros and it would be the same as 0.005. These two would be the same value whether I put the zeros on it or not, right? After your last non-zero digit, you can put as many zeros after it as you want. You're not changing the value of the number. So with that being said, let's compare our two decimals. So we have 0.005351 and 0. Again, lining up the decimal points, 0.05000. So everything is the same until we get to this right here. We have a 3 here and a 0 here. The digit that's larger, 3 is greater than 0. So that tells me that this number right here is going to be the larger number. So we can go ahead and say that 0.0053051 is larger than 0.00, and I can just put 5 here. I don't need to add these zeros at the end. You can do it if it makes you feel more comfortable, but it's the exact same number. All right, let's take a look at one final one. We have 15.489146, question mark, 15.489276. So again, I'm just going to stack the numbers on top of each other. 15.489146, 15.489276. And at this point, you can kind of just start eyeballing things. I can see that everything is the same going down until I get right here. And let me highlight that in light blue. So I have a 1 and I have a 2. 2 is larger, right? 2 is greater than 1. So that tells me that this number right here is going to be bigger. Let me just kind of erase that. This is going to be the bigger number. And so that number is over here. So I would put that 15.489146 is less than 15.489276. And the reason for that is my digit in the 10,000ths place, and this number is a 1. My digit in the 10,000ths place, and this number is a 2. 2 is greater than 1, so that means this number is the larger number. So the last thing we're going to talk about is rounding decimals. And basically, it's the exact same procedure as you used for rounding whole numbers. There's one slight difference, though. And as we're working through the problem, I'm going to explain that to you and why it makes sense. So we want to round 26.13 to the nearest tenth. So the procedure, again, starts out the same. So you have 26.13. So find the digit in the round off place. So where's the tenths place? That's right here. So this is my digit in the round off place. That's a 1. Then I look one digit to the right. That's this 3. And you look for the rule, right? The rule is if it's 4 or less, okay, 4 or less, you leave the digit in the round off place unchanged. If it's 5 or greater, you add 1 to the digit in the round off place. Now, this falls in the category of 4 or less, so I'm going to leave 1 unchanged. Now, when we round whole numbers, we're told that we replace everything after the round off place digit with a 0. When you're working with decimals, they're just going to tell you to cut everything off after the round off place digit. And why does that make sense? Well, if I had followed my procedure for whole numbers, I would have put a 0 here, and that 0 doesn't add any value to the number, so I can just get rid of it. It's different than if I was rounding 2,613. Let's say I wanted to round this number to the nearest 10. Well, this is the round off place. I would look at 3. 3 falls in the category of 4 or less. So I would keep 1 unchanged, and I would change 3 into a 0. In this case, the 0 adds value to the number, right? The number 0 at the end makes it 2,610. If I just erased it, I'd only have 261. Well, it's not the same when you're working with decimals. If I have 26.10 or if I have 26.1, it's the exact same number. All right, let's take a look at another one. We want to round 572.91557 to the nearest hundredth. So 572.91557, again, to the nearest hundredth. So where's the hundredths place? This is the tenths place. Here's your hundredths place. And again, if you forget where your places are, either kind of work with a place value chart, or, again, knowing that this is the tenths, or 1 over 10, I can then move to the right by multiplying by 1 over 10. And 10 times 10 is 100, so I know I would get to 1 over 100, or I'm in the hundredths place. All right, so now that we're in the hundredths place, we look at the digit immediately to the right. That's a 5, so that falls in the category of 5 or greater. So that means I'm adding 1 to the digit in the round off place. So I'm going to have 572.9, 1 plus 1 is 2. And then again, I would replace all of these with zeros, but they don't add any value to the number, so I just leave them off. Right? I can just not put anything else after that too. So my final answer here would be 572.92. Okay, let's take a look at one final problem. We want to round 0.85791356012 to the nearest millionth. So let's rewrite this long number, 0.85791356012. So where's the millionths place? Again, we have the tenths. Once we know that spot, you can kind of just go in a familiar way. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. So here's your millionths place. This is the millionths place. All right, so once we find the digit in the round off place, we look at the digit to the right of it. In this case, it's a 5. 5 is in the category of 5 or greater. So I'm going to add 1 to that 3. It's going to become a 4. So I would have 0.857914. And again, when we round whole numbers, at this point, everything after it becomes a 0. The zeros here, if I change everything to a 0, I'm not changing the value of the number. So I can just delete them, right? I don't need to write that step because, again, 0.857914 is the same as 0.857914, 0, 0, 0, 0, 0. Right? I don't need to put those 5 zeros there. They add no value to the number. Hello and welcome to Pre-Algebra Lesson 41. In this video, we're going to learn about adding and subtracting decimals. All right, for the lesson objective for today, we want to learn how to add and subtract decimals. And this is something where we can kind of just jump right in. It's really easy to add and subtract decimals, especially if you've already mastered vertical addition and vertical subtraction. So to add or subtract decimals, basically all we want to do is write the numbers vertically and line up the decimal points. So you recall when we did multi-digit addition or multi-digit subtraction, meaning vertical addition or vertical subtraction with whole numbers, we stacked the numbers on top of each other and we line them up by place value. Well, it's no different here. We just need to make sure that we line up the decimal points when we stack our numbers on top of each other. The next thing we want to do is bring the decimal point directly down into the answer. So just go straight down, don't deviate. Then lastly, we're going to add or subtract starting with the rightmost column and working your way to the left. So just like we did, again, with vertical addition or vertical subtraction. So for the first problem, we have 0.17, which is basically 0.17, plus 0.3, which is 0.3. Remember, these zeros here don't add any value to the number. We just kind of write them to make it clear that we have some decimal points. So I can just write 0.17 on top of 0.3 and put my addition sign out here and my horizontal line, and I am ready to add. Now, for some people, it makes them more comfortable to have the same number of digits when they're adding. So remember that if you have something like 0.3 or 0.30, it still has a value of 0.3, right? After a decimal point, when I have a non-zero number, like 3, after that number, I can put as many zeros as I want, and I won't change the value. So I could keep putting zeros if I want. It's still going to be 0.3. So with that being said, I can write a 0 in here, and then I can start my addition. Remember, we always start at the rightmost column, and we work to the left. So I would do 7 plus 0, that's 7. Then move to the left. 1 plus 3 is 4. And then I told you in the lesson to bring this down to start. It really doesn't matter when you do it. It's just a matter of remembering to do it. And when you first kind of start working with decimals, sometimes people will forget. They'll just go, okay, the answer is 47. Just make sure that at some point in this procedure, you bring that decimal point straight down into your answer. And so we're going to end up with 0.47. Or again, for clarity, if we want to, we can write 0.47, right? There's no change in the value of that number. All right, for the next one, we have 72.65 minus 31.521. So again, you're just going to stack these numbers on top of each other. So 72.65, that has to go on top because remember, with subtraction, it's not commutative. And then on the bottom, you're going to have 31 point, notice how I'm lining up the decimal points, 521. Okay, so I'm going to write a horizontal line and then my subtraction symbol. And now I'm ready to go. Well, let me go ahead and put the decimal point down. And again, you can do this at any time. I know in the procedure I put that you do it before you start your operation. Really, it doesn't matter. Just remember to do it. Now, when we start in our rightmost column, you're going to find that you have a problem. If I was doing addition here, if I change this to addition, I can just go ahead and bring down the 1. Say, okay, I have a 1 there and keep going. With subtraction, I need to have something that I can take 1 away from, right? So I need something minus 1. Well, remember, I can put a 0 at the end here and not change the value of the number. And I can't do 0 minus 1 without getting a negative. So what I would do is I would just borrow. So I'd borrow from this 5, this would become 4, this would become 10. And now I can do 10 minus 1, that's going to give me 9. 4 minus 2 would give me 2. 6 minus 5 would give me 1. 2 minus 1 would give me 1. And then 7 minus 3 would give me 4. Now, since I already put my decimal point down there, I really don't need to think about it again. I can just write this number as my answer. It's 41.129. All right, now we're going to look at some addition with 3 numbers involved. So we have 0.8274 plus 3.6 plus 12.007. Again, just stack the numbers on top of each other. Just make sure you line up the decimal points. So I'm going to put 0.8274. I'm going to put 3.6. And then I'm going to have 12.007. Now, this is one of the situations where you might want to put some zeros in so that you have the same number of digits for everything after the decimal point. So I can put 3 zeros in here and a 0 here. Again, I'm not changing the value of the number. So when I start my addition problem, again, I'm going to put this down here now to start so I don't forget. I have 4 plus 0, that's 4. I have 7 plus 0 plus 7, that's 14. So put a 4 down and carry the 1. Again, just like you would if you were adding some whole numbers. Then I have 1 plus 2, that's 3. Plus 0, that's still 3. Then I have 8 plus 6, that's 14. Plus 0 is still 14. So put a 4 down, carry the 1. 1 plus 3 is 4. 4 plus 2 is 6. And I can just bring down that 1. So I get 16.4344. So let's write this up here. 16.4344. So what if we have some negatives involved? Well, really, we just kind of use the rules that we used when we added integers together. Just figure out what the sign's going to be first. So we have a negative plus another negative. That's going to give me a negative. And then we can kind of just work with the absolute values. So I can think about 6.13 plus 7.85. So now I would just start in the rightmost column and work my way to the left. 3 plus 5 is 8. 1 plus 8 is 9. And 6 plus 7 is 13. And again, notice how I forgot to bring my decimal point down. So if I wrote 1,398, obviously I would get the wrong answer. So you got to make sure that you bring this down at some point and put it there to where we know we have 13.98 as the answer. Now drag this back up here and put it next to that negative to say we have negative 13.98 as our answer. All right, for the next one I have negative 7.21 plus 3.64. So just think about the fact that if I was adding negative 7 and 3, what would I do here? Well, again, I would use the sign from the number with the larger absolute value. If I kind of get rid of this negative here and think about both numbers as if they were positive, 7.21 would be larger. So we're going to use its sign, right? Its sign is negative. And now we're going to do a subtraction. We're going to take 7.21 and we're going to subtract away 3.64. And let me go ahead and just write this down here before I start so I don't forget like I did in the last problem. So we'll borrow from the 2. It will become a 1. This will become 11. 11 minus 4 is 7. Then I'd have 1 minus 6. I need to borrow again. So borrow from the 7. This becomes 6. This becomes 11. 11 minus 6 is now 5. And then 6 minus 3 is 3. So we get 3.57. Drag that up there and attach the negative to it. And my answer is going to be negative 3.57. Okay, for the next one, we have 128.209 minus 34.55813. So again, just stack the numbers on top of each other. Because it's subtraction, this 128.209 has to go on top. And then 34.55813 is going to go on the bottom. Put my minus sign out here and my horizontal line, and I'm going to bring down my decimal point. Now again, we have a problem because when we go to start subtracting in the rightmost column, I don't have anything to subtract 3 away from. Again, when you have this situation, remember you can put zeros here to kind of fill in these spaces, you're not adding any value to the number, right? It's the same number as it was. And now I can go through and borrow. But I have to go and borrow from the 9. 9 becomes 8. This is going to become 10. Then I'll borrow from the 10. 10 becomes 9. And this 0 becomes 10. So now I can start cranking this out. 10 minus 3 is going to give me 7. 9 minus 1 is going to give me 8. 8 minus 8 is going to give me 0. Now I have 0 minus 5, so I need to borrow. So I'm going to cross this 2 out and put a 1. This 0 will become 10. 10 minus 5 will give me 5. And now I have a 1 over here, so I need to borrow again. This 8 will become 7. This 1 will become 11. 11 minus 5 is 6. Then I'll have 7 minus 4, that's 3. I need to borrow 1 last time. So I'll borrow from the 1, it will become 0. This will become 12. 12 minus 3 is 9. So we end up with 93.65087. So 93.65087. All right, now we have addition and subtraction mixed. So I have 0.685 plus 0.312 minus 5.24 minus a negative 7.035. So the first thing I want you to do is just rewrite this. We have 0.685 plus 0.312 minus 5.24. Minus a negative is plus a positive. So I'm going to put plus positive 7.035. So even though we're not working with integers anymore, we have some decimals involved, the same rules are going to apply. If I'm subtracting away a negative, I'm adding a positive. So I'm just going to work left to right here. And I'm going to start out with 0.685 plus 0.312. Bring down the decimal point. 5 plus 2 is 7. 8 plus 1 is 9. 6 plus 3 is 9. So we get 0.997. So I'm going to put equals 0.997. Let me just put a 0 out here just for clarity. So that took care of those two. And then I'm subtracting away 5.24, and I'm adding 7.035. So the next thing I'm going to do is 0.997 minus 5.24. So let me write this over here. 5.24. So because this is going to result in a negative when I do this subtraction, kind of the easy way to do this would be to reorder everything. Just think about having 0.997 plus a negative 5.24. What would we do in this situation? Well, we know that the answer would be negative. And then what we do is we would just think about the absolute values for a second. Then we would subtract 5.24 minus 0.997. So I'm going to put a 0 here to start. Again, that doesn't add any value to the number. And I'm going to borrow from this 4. This will become 3. And then this is going to become 10. 10 minus 7 is 3. I have a 3 minus 9, so I need to borrow again. So I'm going to borrow from the 2. It becomes 1. This becomes 13. 13 minus 9 is 4. Then I have 1 minus 9. I need to borrow again. This becomes 11. 11 minus 9 is 2. Again, I forgot to bring down my decimal point when I started. But again, as long as you remember to do it at some point, you'll be okay. Then lastly, I have the 4. Nothing to subtract away, so I just bring it down. And I've got 4.243. Now remember, this is negative. I already wrote my negative sign out here. So I'm going to have a negative 4.243. Okay, so there's one more operation to carry out here. And I'm just going to be adding to this 7.035. So negative plus positive, again, we think about what the sign's going to be. And 7.035 is bigger in terms of its absolute value than this negative 4.243. So our answer is going to be positive. And now we just need to subtract. So I'm going to do 7.035 minus 4.243. So 5 minus 3 is 2. So now I want to do 3 minus 4, and I need to borrow. I can't borrow from the 0, so I got to go to this 7. 7 becomes 6. The 0 becomes 10. Then 9. Then finally this 3 becomes 13. 13 minus 4 is 9. Then I'm going to have 9 minus 2, that's 7. And again, I forgot to bring down my decimal point when I started. And so I bring it down now. And then I'll have 6 minus 4, that's 2. So I'm going to get a positive 2.792. So again, when you're adding and subtracting decimals, it's not really any more difficult than when you were just performing vertical addition or vertical subtraction with whole numbers. A couple of things we sprinkled in here, some negatives and some situations where we had to, write some zeros in, but nothing that's really too complicated. Hello and welcome to Pre-Algebra Lesson 42. In this video, we're going to learn about multiplying decimals. So our lesson objective for today is just to learn how to multiply decimals. So before we get started, I just want to mention that multiplying decimals is no more difficult than multiplying whole numbers. If you've already mastered multi-digit multiplication, meaning vertical multiplication, then basically at this point you can already multiply decimals. There's just one additional step that you're going to have to deal with, and that's going to be where you're going to put your decimal point at. So here we go, multiplying decimals. The first thing we want to do, we want to ignore any decimal points and multiply the resulting numbers. So essentially what I'm saying here is that you're going to pretend like your numbers are whole numbers. So if I had something like 5.5 times 3.7, I would start out by pretending I had 55 times 37. Right? I would find the answer for that. Now in the next step, I want to move the decimal point in the answer. And when I say the answer, I mean the answer to the multiplication I just got where I was using whole numbers. So I want to move this to the left by the number of decimal places between all factors. Okay, so between all factors. So let's jump in and look at an example. So we're going to begin today with 5.15 times 0.32. So I'm going to start out, I'm going to ignore any decimal points that I have. And so this number here will be 515. Just going to treat it like it's a whole number. And this number here will be 32. And I just find this product first, and then I'll figure out where to put the decimal point. So 2 times 5 is 10. 0 down, carry the 1. 2 times 1 is 2, plus 1 is 3. 2 times 5 is 10. Okay, I'm going to erase this. And remember, we're moving to the left here, because we're starting over here in the tens place now. 3 times 5 is 15. 5 down, carry a 1. 3 times 1 is 3, plus 1 is 4. And then 3 times 5 is 15. And so now we're going to add. Go ahead and bring down this 0. 3 plus 5 is 8. 0 plus 4 is 4. 1 plus 5 is 6. And then bring down that 1. So what I get is 16,480. But that's obviously not my answer because I haven't figured out where to put the decimal point yet. So just go ahead and come up here, drag this up, 16480. And now we're going to figure out where to put the decimal point at. Now what I told you is that we're going to move the decimal point to the left by the number of decimal places we have between all the factors. So if I look at these two factors here, in 5.15, I have 2 decimal places, 2 decimal places. And in 0.32, I also have 2 decimal places. Okay, we're talking about what's after that decimal point, right? Here I have 2, and here I have 2. So if I combine those two, 2 plus 2 is 4. So between all of the factors here, we have 4 decimal places. So that tells me we're going to have to move our decimal point 4 places to the left. Now when we don't have a visible decimal point, like in a whole number like we have here, we can always write one at the very end of the number, so at the very right part of the number. And now I'm free to move my decimal point 4 places to the left. So I'm going to go 1, 2, 3, 4 places to the left. So my decimal point is going to go right there. And we have an answer that's 1.6480. But remember, I don't need this 0 here. I can erase it because that 0 does not add any value to the number. After your decimal point, or to the right of the decimal point, after your final non-zero digit, you can add as many zeros as you want. So I could put 0, 0, 0, 0, 0. It's still 1.648, right? These zeros do not change the value of the number at all. All right, so again, our final answer here will be 1.648. Okay, for the next one, we have 0.00153 times 2.71. So again, I'm going to ignore the decimal points, and I'm going to pretend like I had 153 times 271. And I just multiply. So 1 times 3 is 3, 1 times 5 is 5, and 1 times 1 is 1. Now I'm going to the tens place, so I need to move to the left in my answer. 7 times 3 is 21. Put a 1 down, carry the 2. 7 times 5 is 35, plus 2 is 37. 7 down, carry the 3. 7 times 1 is 7, plus 3 is 10. And move over one more time. We're going to the hundreds place. 2 times 3 is 6. 2 times 5 is 10. 0 down, carry the 1. 2 times 1 is 2, plus 1 is 3. All right, so let's add now. Get rid of these arrows, bring down the 3. 5 plus 1 is 6. 1 plus 7 is 8, plus 6 is 14. 4 down, carry the 1. 1 plus 0 is 1. And then 1 plus 3 is 4. So we end up with 41,463. But again, that's not our answer, right? We can just drag this up to the top here. And just to get a little room going, I'm just going to erase this. So again, it was 41,463. My next step is to figure out where I'm going to put the decimal point in this number. If I look between the two factors here, I need to count how many decimal places I have. In this number, I have 1, 2, 3, 4, 5 decimal places, right? 5 decimal places. In this number over here, I have 2. 1, 2 decimal places. So between all the factors, or between both factors, I have 5 plus 2, or 7 decimal places. So that tells me I need to move my decimal point 7 places to the left. Let me erase this real quick. And we'll put a visible decimal point to the right of that 3. Remember, if you have a whole number, you can just put it at the end of the whole number. And we're going to move the decimal point 7 places to the left. So 1, 2, 3, 4, 5. And do I stop now? No, I put some zeros in, right? So I put a 0 in here so that I can do 6. And then one more 0 so that I can do 7. And so I put my decimal point there. I can erase all this at this point and say that my answer is 0.0041463. All right, let's take a look at one with a negative involved. So we have negative 3.01 times 1.8. So remember, when we worked with integers, we learned that a negative times a positive is a negative. The rules are the same for all real numbers. So when you come across a negative times a positive, you're always going to get a negative. Doesn't matter if you're multiplying fractions or decimals or whole numbers or integers. Whatever you're doing, negative times positive is negative. Now, once we figure out the sign, remember, we can just work with the absolute value. So I could just pretend like I had positive 3.01 times positive 1.8. And when we multiply decimals, remember, the first step is just to ignore the decimal point and pretend like we had whole numbers. So 301 times 18. So 8 times 1 is 8. 8 times 0 is 0. 8 times 3 is 24. Now we're moving to the left because we're going to the tens place. We're doing 1 times 301. That's 301. So I'm going to write a 1, a 0, and a 3. And now we're going to add. So just bring down this 8. 0 plus 1 is 1. 4 plus 0 is 4. 2 plus 3 is 5. So I get 5,418. And again, this is not my answer. I'll write this up here next to this negative 5,418. And I can go ahead and erase this now. And let's just figure out where we're going to put our decimal point at. Again, I'm looking for how many decimal places I have between the factors. So here I have 2 decimal places. 2 decimal places. Here I have 1 decimal place. So what that means is that between all the factors, or between both factors here, I have 3 decimal places. So my decimal point is going to go 3 places to the left. So I'm going to put it right there to start. And then I'm going 1, 2, 3 places to the left. So I'm going to end up with negative, okay, don't forget the negative out here, 5.418 as my answer. Okay, let's take a look at one final problem, and then we'll kind of jump into a section where we'll talk about multiplying by 10 or power of 10, something that's going to help you speed up your multiplication. All right, so we have negative 19.06 times 0.0051 times negative 2.02. Now, what we're looking at here is we have a negative times a positive times a negative. Now, we know from working with integers that if we multiply more than two numbers and we have an even number of negatives, we're going to get a positive result, right? Each pair of negatives makes a positive. So I'm just going to go ahead and write that the answer is going to be positive. And now we can just think about these numbers as if they were all positive, right? We can just think about the absolute values. Now, the next thing we want to do is multiply any of the two numbers together. And so I'm going to start out with 19.06 times 0.0051. So to do that, I'm going to pretend this is 1,906 times 51. So 1 times 1,906 is 1,906. Then I'm moving to the left here, so I move to the left when I put my answer down. 5 times 6 is 30. 0 down, carry the 3. 5 times 0 is 0, plus 3 is 3. 5 times 9 is 45. Put a 5 down, carry the 4. 5 times 1 is 5, plus 4 is 9. So now let's add. Bring down the 6. 0 plus 0 is 0. 9 plus 3 is 12. 2 down, carry the 1. 1 plus 1 is 2, plus 5 is 7. Bring down the 9. So I get 97,206. So let me write that here, 97,206. Now, at this point, you can figure out where the decimal point would be based on these two right here, or you can keep going and multiply this number times this number here as if it was 202. Now, both ways will work. I think it's a little faster if we just figure out where the decimal point is going to be in the end. So let's go ahead and do that. So I'm going to think that I have 97,206 times 202 for right now. Okay, so 97,206 times 202. And once we figure this out, we're going to put our answer here. We're going to go back and figure out where the decimal point should be. So 2 times 6 is 12. Put a 2 down, carry the 1. 2 times 0 is 0, plus 1 is 1. 2 times 2 is 4. 2 times 7 is 14. 4 down, carry the 1. 2 times 9 is 18, plus 1 is 19. Now I know 0 times anything is 0, so that would have started here. I'll just put 1 0 there. Then we're going to the 2. 2's in the hundreds place, so I'm moving over one more time. My answer is going to start there. 2 times 6 is 12. 2 down, carry the 1. 2 times 0 is 0, plus 1 is 1. 2 times 2 is 4. 2 times 7 is 14. Put a 4 down, carry the 1. Then lastly, 2 times 9 is 18, plus 1 is 19. So now we're going to add. Go ahead and bring down the 2. 1 plus 0 is 1. 4 plus 2 is 6. 4 plus 1 is 5. 9 plus 4 is 13. Put a 3 down, carry the 1. 1 plus 1 is 2, plus 4 is 6. Bring down the 9, bring down the 1. So we end up with 19,635,612. So let's erase this, and we're going to write that up top. So now we want to just figure out where our decimal point should be in this answer. So to do that, we count the total number of decimal places between all of the factors. So if I come here, I have 2 decimal places. So 2 decimal places. Here I have 1, 2, 3, 4. So 4 decimal places. And here again I have 2 decimal places. So 2 plus 4 is 6. 6 plus 2 is 8. So that means I need to move my decimal point 8 places to the left. So I'm going to start it right here. And let me kind of make this number a little bit straighter. So again, put the decimal point here. And we're going 8 places to the left. So 1, 2, 3, 4, 5, 6, 7, and finally 8. So that decimal point is going to go out in front. And we have 0.19635612 as our final answer. So for this next section, I want to talk a little bit about multiplying by 10 or a power of 10. And when I say power of 10, let me just explain that I'm talking about an exponent on 10 that's going to be a whole number that's 1 or larger. So for example, you'd have something like 10 to the first power, which is just 10. 10 squared, which is 100. 10 cubed, which is 1,000. 10 to the 4th power, which is 10,000. 10 to the 5th power, so on and so forth, right? I'm not talking about raising it to 10 to the power of -4, right? I'm only including these values here. So for the trick, essentially what you're going to do is you're going to move your decimal point one place to the right for every 0 in the power of 10. So let me give you something to start with that you're already familiar with. Let's say you had the number 5 and you multiply it by 10. Well, we already know that this is 50. But one of the ways you can figure this out is you can put a decimal point behind 5, right? You can do that with a whole number. And I can put a 0 behind that decimal point, perfectly legal. If I'm multiplying by 10, really all I need to do is take that decimal point and move it to the right one place, because there's 1 0 here. So that tells me that the answer is 50. If I took 5.0 and multiplied it by 100, okay, by 100, there's 2 zeros in 100, so 5.0, move this 1, put another 0 in, 2 places to the right, and I'd get 500. I could do the same thing with 1,000 or 10,000, so on and so forth. Now, really 100 is just 10 squared. So I could replace this 100 with 10 squared if I want. And I know that if the exponent is a 2, I'm going to have a 1 followed by 2 zeros, right? So it's 1 followed by 2 zeros. This tells me how many zeros I'll have. So without even converting 10 squared to 100, I know I just take 5.0 and move that decimal point 2 places to the right to get 500. And so if I ran across something like 5.0 times 10 to the 9th power, I know I would do 5 point, and then I would basically just move this 9 places to the right. So let's do that. Go 1, 2, 3, 4, 5, 6, 7, 8, 9. So because this is all the way out there, I'm going to use some commas now. And we'd end up with the number 5 billion. All right, so let's try some basic ones here. We have 0.015 times 10. So I'm going to take this decimal point and move it one place to the right. And so I'd end up with what? I would end up with 0.15, or I could put a 0 out in front. I have 0.15 in that case. What about in the case of 0.015, same number as above, times 10 squared? Well, really all I need to do is move this one place to the right from here because I have one additional 0. Here I have 1 0, here I have 2, right? I can just look at the exponent. So I can take this number, 0.15 basically, move it one place to the right, and I'd have 1.5. Or you can do it from here and just say, okay, I have 2 places to move my decimal. And again, I get 1.5. In this case, I'm moving the decimal 4 places to the right. Right? I'm multiplying by 10 to the 4th power. There's going to be 4 zeros in that power of 10. So what I want to do is go 1, 2, 3, add a 0, and then finally 4. So that's going to give me 150 or 150, right? Because if I kept this 0 out in front, it would add no value to the number. 0150 is the same thing as 150, right? So that's how we would read that number. Here's an example where this would really come in handy. Let's say you get this on a test. Negative 23.2815 times 0.001 times 10 squared. If you do this without using any technique, it might take you a little while. But the first thing I do is I kind of eyeball it and I see that, okay, 10 squared times 0.001, I can just move this 2 places to the right and have 0.1. So essentially this problem just becomes negative 23.2815 times 0.1, or for clarity we can do 0.1. Now I know that negative times positive is negative, so I know the answer is negative. So if I were to pretend these are whole numbers, I would do 232,815 times 1. Well, that's just going to give me 232,815. At that point, I just have to figure out where to put my decimal point. And I'd say, okay, well, I have 1, 2, 3, 4, 5 decimal places between both factors here. So the decimal point's going to go 1, 2, 3, 4, 5 places to the left. And I'd end up with negative 2.32815. All right, for the final problem, we have 0.012456 times 100 times 1,000. So 100, most of you should know at this point, is 10 squared, right? That's a power of 10, and the exponent is a whole number that's 1 or larger. 1,000 is also a power of 10. It's 10 cubed, right? So same scenario. So we can use our trick here, and you basically can count the number of zeros between both of these. You have 1, 2, 3, 4, 5, because if I was to multiply these two numbers together, let's say I started out by saying, what is 100 times 1,000? Well, using my trick for trailing zeros, I know that I would do 1 times 1, that's 1, and then I would attach 5 trailing zeros, right? So 1, 2, 3, 4, 5. I'd get the number 100,000, or we could write that as 10 to the 5th power. So let me put this over here, 0.012456. And now to do this multiplication, all we need to do is move our decimal point 5 places to the right, right? Because we have 1, 2, 3, 4, 5 zeros in this power of 10. So let me copy this number. We're going 1, 2, 3, 4, 5 places to the right. And I can delete this 0 and this 0. I don't need them anymore. They're not going to add value to the number. And so we would have 1,245.6. Hello and welcome to Pre-Algebra Lesson 43. In this video, we're going to learn about dividing decimals. So our lesson objectives for today, we want to learn how to divide a decimal by a whole number. And also we want to learn how to divide a decimal or whole number by a decimal. So before I started talking about multiplying decimals, I told you that it was really no more difficult than multiplying whole numbers. You just have an extra step involved. Well, it's really the same thing here. Some cases you're going to have 1 extra step, in some cases you'll have 2 extra steps, just depending on what the situation is. But if you can divide whole numbers using long division, you can divide decimals. It's no more difficult. So let's start out by saying to divide a decimal by a whole number, which is the easier scenario, we just want to set up the long division normally and place the decimal point in the answer directly above the decimal point in the dividend. Now I know we haven't talked about division in a while, so just remember if you have something like 6 divided by 3 equals 2, the 6, the amount you start with is the dividend. 3, the amount you're dividing by is the divisor. And 2, the answer that you get, or the result, is the quotient. So once you've performed this step, where we place the decimal point in the answer directly above the decimal point in the dividend, you just divide normally, right? You can just ignore the decimal point, pretend like it's not there because you already know where it's going to be in your answer. All right, let's start out with 1.5 divided by 3. So we set up our long division normally. So I take my dividend, which is 1.5, and that goes underneath. I take my divisor, which is 3, and I put it off to the left. Now, the first step we're going to do is we're going to take this decimal point, and we're going to bring it straight up into the answer. Make sure it lines up properly, otherwise you won't get the right answer. Now, once I've done that, I know where the decimal point's going to be, and I can just pretend I have 15 divided by 3, right? So I would say, what is 3 going into 1? Well, we can't do that. So how many times would 3 go into 15? Well, that would go in 5 times. So I put a 5 here, and then I multiply. 5 times 3 is 15, and I subtract, and I get 0. So my answer for this is going to be 0.5, or I could put 0.5. Now remember, we can check division with multiplication. So we already know how to multiply with decimals. I could do 0.5 times 3, right? I could go backwards, and I should get 1.5. So what is 0.5 times 3? Well, we already know that we do 5 times 3. That would give us 15. And I would look to see how many decimal places I have between the factors. Well, this has 1 decimal place. This really doesn't have any. So I would move my decimal point 1 place to the left, and I would end up with 1.5, which is exactly what I started with as my dividend. Right? So we know that this answer is correct. 1.5 divided by 3 is 0.5. Let's take a look at the next one. We have negative 2.17 divided by 7. Now, again, if you're multiplying or dividing with negatives, the same rules that we learned with integers are going to apply. Negative divided by positive is negative. Once you find out the sign, you can just pretend like all the numbers are positive. You don't need to think about it anymore. So I'm just going to set up my long division as 2.17, and we're dividing by 7. Now, bring your decimal point straight up into the answer, and then you're done with it. You don't have to think about it anymore. You can just divide, like if you had 217 divided by 7. So 7 is not going to go into 2, but 7 will go into 21. It goes in exactly 3 times. 3 times 7 is 21. Subtract and get 0. Bring down the 7. 7 will go into 7 one time. 1 times 7 is 7. Subtract and get 0. So we have 0.31 as our answer. But remember, we have this negative up here. So let's attach that. And we'll say that we have negative 0.31 as our answer. And again, when you first start doing this, it's good for you to check, right? Take your quotient, your answer, multiply it by the divisor, you should get the dividend. So let's do one more where we check it. And then in the future, I'll leave it up to you to check your work. But it's good practice to check because you just learned how to multiply decimals. And so it can kind of reinforce what you learned. So you can take negative 0.31, and we're multiplying this by 7. So what is 7 times 31? So 31 times 7. 7 times 1 is 7. 7 times 3 is 21. So we would have 217 there. Remember, it's a negative times a positive, so that gives us a negative. And then we just need to figure out how many decimal places we have between the factors. Well, we have 1, 2, right? None over here. So this would go 1, 2 places to the left. You'd have negative 2.17, which is exactly what you have here as your dividend. So again, you know your answer is correct, right? Our answer here is negative 0.31. Okay, for our next one, we have 44.95 divided by 31. So again, let's set this up. 44.95 divided by 31. Bring this up into the answer so you can forget about it. And now you just divide normally. So 31 will not go into 4, but it will go into 44. It'll go in once. 1 times 31 is 31. Subtract here and you would get 13, right? 4 minus 1 is 3. 4 minus 3 is 1. Now bring down the next number. How many times will 31 go into 139? Well, let's see. I know that 31 times 10 is 310. 310. Let's say I was to mentally cut that in half. Think about 310 as 300 plus 10. Cut 300 in half, you'd have 150. Cut 10 in half, you'd have 5. So half of this would be 155. That's too big. So my guess is going to be for 4. So what is 31 times 4? 4 times 1 is 4. 4 times 3 is 12. That's 124. So that's as close as we can get without going over. So we're going to put a 4 here, and we're going to multiply. 4 times 31 again is 124. Now we're going to subtract. 9 minus 4 is 5. 3 minus 2 is 1. So we'd have 15 there. And then we're going to bring down the 5. Now, we figured out earlier that 31 times 5 was 155, right? We just saw that. So I know that 31 will go into 155 5 times exactly. So this is going to be a 5. 5 times 31 again is 155. Subtract and we get 0. So we get 1.45 as the answer. And let me just scroll back up here and write this next to this. So equals 1.45. So now we're going to kind of use this information to kind of tackle something that might have been confusing you for a while. I know that a lot of you will do division on a calculator. Let's say you have something like 17 divided by 5. So if you perform this operation using long division, 5 doesn't go into 1. 5 goes into 17 3 times. 3 times 5 is 15. You subtract and you get 2. So kind of up to this point, we've written 3 with a remainder of 2 as our answer. Now, your calculator won't give you 3 with a remainder of 2. It's going to tell you that the answer is 3.4. So how do we go from this format to the 3.4 format? Well, that's what we're going to get to right now. So let me erase this real quick and kind of give you the backstory. So I want you to recall that after a decimal point, a 0 does not add value unless it precedes a non-zero number. So something like 5.000000 is still 5. Right? Where you run into problems if you had something like 5.000001, well, these zeros do matter now. right? Because they come before a non-zero digit. They precede a non-zero number, okay? But if you don't have anything that's out there other than 0, you can put as many as you want. It doesn't matter. You're not adding value to the number. So knowing that, let's explore that 17 divided by 5 again and see if we can get 3.4 as our answer. So 17 divided by 5. So the first thing I'm going to do is I'm going to write 17 as 17 point, and I'm going to put 1 0 behind it. I'm going to put this decimal point up here in the answer, and now I'm going to divide like I normally would. 5 won't go into 1, so we say 5 goes into 17 3 times. 3 times 5 is 15. Subtract and get 2. Now instead of stopping and saying that's my remainder, I can bring down this 0. 5 goes into 24 times. 4 times 5 is 20. Subtract and get 0. So now you see what your calculator is doing. It's just continuing the division, right? So our answer here is 3.4. It doesn't make it wrong if you say you have 3 with a remainder of 2. It's just a little bit more precise to use this method and say, okay, well, our answer is 3.4. Let's try another one. So let's say we had 6.2 divided by 5. So 6.2 divided by 5. So we already have a decimal point here. Let's bring that up into the answer. And let's divide. 5 goes into 6 once. 1 times 5 is 5. Subtract and you get 1. Bring down the 2. 5 goes into 12 twice. 2 times 5 is 10. Subtract and get 2. So we're not going to say that we have 1.2 with a remainder of 2. We're going to continue the division. So remember, if I have 6.2, I can legally add as many zeros after that 2 as I want, not changing the value of the number. So let's continue our division. Let's put a 0 here, and then let's bring it down. So 5 will now go into 20 exactly 4 times. 4 times 5 is 20. Subtract and get 0. So our answer here is going to be 1.24. So we're going to get 1.24. And this is basically what we're going to do from here on out. We're going to continue the division until we get an answer, or sometimes we're going to get a digit that repeats or a pattern of digits that repeat. And we'll get to an example of that in a minute. All right, let's take a look at another one. We have 65.98 divided by 50. So 65.98 divided by 50. So bring your decimal point up into the answer. 50 is not going to go into 6, but it will go into 65. It'll go in once. 1 times 50 is 50. Subtract, 5 minus 0 is 5. 6 minus 5 is 1. And go ahead and bring down the 9. So now how many times will 50 go into 159? Well, 50 times 3 is 150. And that's about as good as we can do. So let's put a 3 here. 3 times 50, as I just said, is 150. Subtract 2, we get 9. Bring down the 8. And let me scroll down and get a little room going here. So I know that 50 is going to go into 98 once. Only once. 1 times 50 is 50. Subtract, and we'd have 48, right? 8 minus 0 is 8. 9 minus 5 is 4. So we continue, right? We put a 0 after the 8, and we bring that down. So now we're going to ask, how many times will 50 go into 480? Well, I know 50 times 10 is 500, so I'd have to do 50 times 9. So 9 times 5 is 45. Attach a 0, it's 450. Let me kind of go back and forth here because we're not going to be able to fit all this on the screen. So 450, subtract, and you'd have 30. So I can keep adding zeros until I have something. So I'm going to add another 0 here and drag that down. I'm going to drag that down. So now I have 300. Now let me scroll up. So 50 goes into 300 exactly 6 times. So put a 6 here. And 6 times 50 again is 300. And when we subtract, we're going to have 0. So there's no remainder. So go up here. And our answer is going to be 1.3196. So let's take a look at this other scenario that you're going to run into. Occasionally, we're going to get a digit or series of digits that repeat forever. So when this occurs, we place kind of a bar over the part that repeats. So if I got an answer that was 4.333333, and that 3 just kept continuing forever, what I do is I just put a bar over the 3. Or if I had 3 digits like 367, 367, 367, I would just erase these and put a bar over the 3, 6, and 7, right? The part that repeats. Let's look at 1.3 divided by 6. So 1.3 divided by 6. So bring this up into the answer. 6 doesn't go into 1. It goes into 13 twice. 2 times 6 is 12. Subtract and get 1. Put a 0 here to continue the division. bring that down. 6 is going to go in at 10 once. 1 times 6 is 6. Subtract and get 4. Put a 0 to continue the division. Bring that down. 6 is going to go into 46 times. 6 times 6 is 36. Subtract and get 4. Put a 0 to continue the division. Bring that down. 6 goes into 46 times. 6 times 6 is 36. Subtract and get 4. Now, a lot of you at this point can already see there's an issue. Every time you continue this, if I put another 0 here and bring it down, I'm going to have 40 again. I had 40 here, then here, then here. It's just going to keep going because every time you're going to ask, how many times will 6 go into 40? Well, it's going to go in 6 times. So I'm going to have another 6 up there. I'll multiply. 6 times 6 is 36. I'm going to subtract 40 minus 36, and I'm going to get a 4. Bring down another 0. I'll have 40 again. This will continue forever and ever and ever. So once you recognize that there's a pattern going on, you just stop. And you say, okay, the 6 will repeat forever. So my answer is 0.216 with a bar on top of the 6. Okay, a bar on top of the 6. That way we know that that 6 continues forever. All right, let's take a look at another one where you'll have a pattern that continues forever. So you have 51.2, and we're dividing this by 11. So bring that up into the answer, and 11 will not go into 5. It's going to go into 51 4 times. 4 times 11 is 44. Subtract here. I would need to borrow. This would become 4. This would become 11. 11 minus 4 is 7. 4 minus 4 is 0. So I'll go ahead and bring down this 2 here. 11 will go into 72 6 times. 6 times 11 is 66. Subtract. I need to borrow. 12 minus 6 is 6. So I'm going to put a 0 here so I can continue. And I have 60. 11 goes into 65 times. 5 times 11 is 55. Subtract and I get 5. Go ahead and put a 0 here and bring that down. 11 goes into 54 times. 4 times 11 is 44. Subtract and you're going to get 6. So we're going to bring down another 0. And we're going to have 60. And remember, the divisor is 11. I don't want to scroll back and forth. The divisor is 11. So you'd say, how many times does 11 go into 60? Well, it's going to go in 5 times. It's going to go in 5 times. So this will be a 5. 5 times 11 is 55. 55. And subtract. You can already kind of see what pattern is going to emerge, right? You have 60 minus 55 here, and then you have it here again. So you know the result is going to be this next, right? Underneath it, I could basically just write 50 and 44 and minus and keep going, right? That's the pattern. But let me erase this real quick and say that, okay, this will be 5. This will be 10. 10 minus 5 is 5. And again, I'd bring down a 0 from all the way up top. Let me do that. And we'd have 50 again. 11 will go into 50 only 4 times. Only 4 times. So you can really see that it's 5, 4, 5, 4, 5, 4. That's the pattern that's going to continue forever. So 4 times 11 is 44. Subtracting, you get 6. So again, you're going to start out with 60 again, right? You have 60 here, and then you go to 50, then 60, then 50, and then that's exactly what's happening again. You'd have 60, you go through that again, you'd have 50, so on and so forth. It would just continue forever and ever and ever. So when you notice your pattern, you can go ahead and just stop and say, okay, I have 4.654. Now, the 5, 4 is what's repeating forever. So I'm going to put that bar over the 5 and the 4 only. But make sure you cover both digits, whatever's repeating. So I'm basically demonstrating that the 5 and the 4 will continue forever. So in other words, 4.654, 54, 54, 54, so on and so forth. All right, so now another important fact. Now, when we talked about multiplying decimals, I kind of worked into the situation when we multiply by 10 or a power of 10. And when I say a power of 10, I mean a whole number that is 1 or larger. So we're talking about 10 to the first power, 10 squared, 10 cubed, 10 to the fourth, so on and so forth. We saw that we'd move the decimal point one place to the right for every 0 in the power of 10. So if I did, 96 times 10 cubed, well, 10 cubed is a power of 10 with 3 zeros, right? It's 1,000. This is basically 96 times 1,000, right? So I have 1, 2, 3 zeros there. So I'm going to move the decimal point 3 places to the right. I'd go 1, 2, 3. and it ended up with 96,000 as an answer. When we divide by 10 or a power of 10, when I say power of 10 again, I'm saying a whole number that's 1 or larger, we're going to kind of do the reverse. We're going to move the decimal point one place to the left for every 0 in the power of 10. So multiplying, it's going to the right. Dividing, it's going to the left. So if I have 96.12 divided by 10, the shortcut is just to say, okay, I have 1 0 going to the left by 1. That would be 9.612. If I have 96.12 divided by 100, the shortcut is to say, okay, I have 2 zeros, so I'm going to go 1, 2 places to the left, so I'd have 0.9612. If I have 96.12 divided by 10,000, I have 1, 2, 3, 4 zeros in this power of 10. So I'm going to have 96.12. I need to put 2 zeros over here. I'm going to go 1, 2, 3, 4 places to the left, and I'll end up with 0.009612 as my answer. Okay, let's talk about the other scenario now. So our other scenario involves dividing by a decimal. And basically what we're going to do here, we're going to move the decimal point in the divisor by enough places right to make it into a whole number. Now, once we've done that, our kind of next step is to match that movement with the decimal point in the dividend. So as a quick example, let's say I'm dividing 6.3 by, 3.27. What I want to do is I want to start out with my divisor. Remember, that's the number you're dividing by. And I want to make it into a whole number. So I'm basically going to move this decimal point 2 places to the right. I just have to match that movement in my dividend. So for 6.3, I'm going to put a 0 behind the 3, and I'm going to move this 2 places to the right as well. So I'm basically turning this into the division problem, 630 divided by 327. Now you might stop for a minute and try to figure out how that's legal. The best way I can explain it to you is if you put it in fractional form, you can kind of think about having 6.3 in the numerator over 3.27 in the denominator. And let's say I just multiply the numerator and denominator by 100. Remember, that's just like multiplying by 1. So we would end up with, again, 630 over 327. So let's take a look at a few examples. So if I have 91.35 divided by 6.09, this is the divisor. This is the divisor. And essentially what I'm doing is I'm saying, okay, I need to move this 2 places to the right to make it a whole number, to make it the number 609. I just need to match that over here and move this 2 places to the right. Basically, I'm just multiplying each by 100, right? We learned earlier if you multiply by 10, you go 1 place to the right. If you multiply by 10 squared or 100, there's 2 zeros there, so you go 2 places to the right. And that's all we're doing. In fractional form, you can kind of think about this set up this way. If I just multiply the numerator and denominator here by 100, what I'm going to end up with is what? I'm going to end up with 9,135 over 609. Right? That's all I'm basically doing. I'm matching the movement that was made in the divisor that made it into a whole number in my dividend. Right? So that's the first thing we want to do. So once we have that, I'll just rewrite this problem. I'll just say it's 9,135 divided by 609. And we'll just crank that out real quick. So 609 will go over here. 9,135 will go here. Let me scroll down and get some room going. And so 609 will go into 913, right? It's not going to go into 9 or 91, but 913 once. 1 times 609 is 609. We would subtract here, and I'll borrow here. 13 minus 9 is 4. 0 minus 0 is 0. 9 minus 6 is 3. So that's 304. Bring down the 5. So we have 609. How many times is that going to go into 3,045? Well, you can eyeball this and see that it's going to work out perfectly, right? Think about 609 as 600 plus 9. If I multiply 600 times 5, I get 3,000. If I multiply 9 times 5, I get 45. So that tells me that what I'm looking for here is a 5. Right? 5 times 609 is going to give me 3,045. 5 times 9 is 45. 5 down, carry the 4. 5 times 0 is 0, plus 4 is 4. 5 times 6 is 30. So again, 3,045. So again, 5 times 609 is 3,045. Subtracting gets 0. So your answer here is just 15. So let me erase this and we'll scroll up and write that down. That our answer is going to be 15. Now let's take a look at one more. All right, so we have 183.4272, and we're going to divide this by 21.23. So again, I'm looking at my divisor, and I want to make it into a whole number. So I need to move this 2 places to the right. Basically, I'm multiplying it by 100. I need to match that movement over here in the dividend. So I'm going to move this 2 places to the right. A lot of students get confused at first. They can't remember what they need to move. Remember, it's always the divisor, what you're dividing by, that you need to change it to a whole number. So I'm going to write this problem now as 18,342.72 divided by 2,123. So now let's crank this out. I have 18,342.72. Again, I'm dividing this by 2,123. And when you work with really big numbers like this, it can be very, very tedious. And I doubt you get something like this on a test. If you did, it would probably be like your final question or something like that. I just like to do some examples that are a little bit challenging so that you get experience working with something that's very tedious. So 2,123, it's not going to go into 1. It's not going to go into 18. It's not going to go into 183. It's not going to go into 1,834. The first thing we could check is 18,342. So we got to make some guesses. I would guess with a 9, that's probably going to be too big. So 2,123 times 9. 9 times 3 is 27. 9 times 2 is 18, plus 2 is 20. 9 times 1 is 9, plus 2 is 11. 9 times 2 is 18, plus 1 is 19. So that's 19,107. That's too big. So we're going to go with 8. So I'll put an 8 here. And let's do that multiplication real quick so we can get our product going. 8 times 3 is 24. 8 times 2 is 16, plus 2 is 18. 8 times 1 is 8, plus 1 is 9. 8 times 2 is 16. So I'm going to get 16,984 as my answer there. 16,984. We're going to subtract. And I'll need to borrow here. This will become 3, then 12. 12 minus 4 is 8. We'll borrow again. This will become 2. This is 13. 13 minus 8 is 5. We'll borrow again. This will become 7. This will become 12. 12 minus 9 is 3. 7 minus 6 is going to give me 1. And then 1 minus 1 is 0. So I get 1,358. 1,358. And I'm going to bring down my 7. So now I'm working with 13,587. So again, I'm going to make a little guess. So what I do is I think about, okay, 2,000 times 6 would give me 12,000. Let's just try that out first. So 2,123 times 6. Let me scroll down. Get a little room going. 6 times 3 is 18. 6 times 2 is 12, plus 1 is 13. 6 times 1 is 6, plus 1 is 7. 6 times 2 is 12. So 12,738, that's as close as we're going to get. 12,738 is as close as we can get. So 2,123 will go into 13,587 6 times. 6 times 2,123, again, is 12,738. So now we want to subtract. And let me just move this over a little bit. So I'm going to borrow here to start. This will become 7. This will become 17. 17 minus 8 is 9. 7 minus 3 is 4. Borrow again. 15 minus 7 is 8. 2 minus 2 is 0. 1 minus 1 is 0. So basically I have 849. And I'm going to bring down this 2 here. So I get 8,492. So how many times will 2,123 go into 8,492? Well, I'm going to guess 4, right? Because 2,000 times 4 will be 8,000. So let's check that out. What would 2,123 times 4 give me? 4 times 3 is 12. 4 times 2 is 8, plus 1 is 9. 4 times 1 is 4. 4 times 2 is 8. So 2,123 will go into 8,492 exactly 4 times. 4 times 2,123 is 8,492. Subtract, and we will get 0, and we are done. Our answer here is going to be 8.64. Let's go back up to the top and write that in. So this is going to be 8.64 as our final answer. Hello and welcome to Pre-Algebra Lesson 44. In this video, we're going to learn about changing fractions to decimals. So our lesson objective for today is just to learn how to change a non-decimal fraction into a decimal. And the procedure for this is very, very, very simple. To convert a non-decimal fraction, remember a decimal fraction is a fraction whose denominator is 10 or a power of 10. So again, to convert a non-decimal fraction into a decimal, we divide the numerator by the denominator. Very, very easy to do. So let's start out with something like 1/4. So all we need to do is take the numerator, which is 1, and divide it by the denominator, which is 4. Now, in the case of a proper fraction, like you have here, your numerator is smaller than your denominator. So what you're going to have to do is put a decimal point at the end of your dividend, bring it up into the answer, and then put a 0 after that decimal point. Now we can do our division. So we would ask, how many times will 4 go into 10? Well, it will go in twice. Multiply 2 times 4, you're going to get 8. Subtract here, you will get 2. And I could put another 0 so I can continue my division. Go ahead and bring that down. 4 goes into 25 times. 5 times 4 is 20. Subtracting, you would get 0. So 1/4 is the same as 0.25, or you could write 0.25. All right, let's take a look at another one. We have 2/3. So again, I'm going to divide the numerator by the denominator. So 2 is going to be divided by 3. Now 2 is smaller than 3, so I know that I have to put my decimal point after 2. Bring that up into the answer, put a 0 behind it, and now I can start my division. 3 will go into 26 times. 6 times 3 is 18. Subtracting, you would get 2. I could put another 0 and bring that down. 3 goes into 20. Again, 6 times. 6 times 3 is 18. Subtracting, you would get 2. And I could keep doing this, but obviously at this point, most of you have recognized that you're going to have an infinitely repeating digit, right? Every time I'm going to bring down a 0 and get 20, and I'm going to ask that same question. How many times does 3 go into 20? You're going to keep getting 6. You're going to multiply 6 times 3, you're going to get 18. You're going to subtract, you're going to get 2 again. So it's kind of an infinite loop, right? It will never stop. So as I taught you in the last lesson where we covered dividing decimals, basically what you're going to do is you're going to put 0.6, or you could do 0.6, and you're going to put a bar, a horizontal bar, on top of that 6 to denote that that 6 is a repeating digit, right? It will repeat forever. Okay, for the next one, let's look at 2/11, or 2/11. So again, I want to divide the numerator by the denominator. So 2 is going to be divided by 11. And again, 2 is smaller than 11, so I'm going to put a decimal point after 2, bring that up into the answer, and put a 0 after that decimal point. And now I can just ask, how many times will 11 go into 20? It's going to go in once. 1 times 11 is 11. Subtract here and you get 9. So I can put another 0 so I can continue my division. Go ahead and bring that guy down, and you'll have 90. 11 goes into 98 times. 8 times 11 is 88. Subtracting, you get 2. Now to continue the division, I put a 0 here and bring that guy down. Now notice how I started out with the question, 11 goes into 20, and I got 1. Again, I'm asking that question. 11 is going to go into 20 once. So you can already see that you're going to have a pattern that's going to repeat. It's going to be 1, 8, 1, 8, 1, 8, so on and so forth. Because 11 is going to go into 20 again. We put 1 there. We multiply. 1 times 11 is 11. When we subtract, we're going to get 9. We're going to put another 0 here and bring this down. And again, we're going to ask, how many times does 11 go into 90? That's going to be 8. 8 times 11 is 88. Subtracting, we're going to get 2. Right? So it's the same pattern over and over again, where I have basically 20, then 90. Then this would be 20 again, then you'd have 90 again. You know, so on and so forth. So we can stop at this point and go ahead and give an answer. It's going to be 0.18, where the 1 and the 8 repeat forever. So we'll put a horizontal bar on top of the 1 and the 8. Very important. And if you want, you can put a 0 out here just for clarity. So our answer is going to be 0.18, where the 1 and the 8 repeat forever. All right, let's take a look at another one. We have 25/44. So I'm going to take 25, my number in the numerator, and divide that by 44, my number in the denominator. And again, 25 is smaller than 44, so I'm going to begin by putting a decimal point there, bringing that up into the answer, and then putting a 0 behind that decimal point. So now how many times will 44 go into 250? A lot of us don't really work with 44 that often, but just think about 44 times 10. 44 times 10, that's 440. Obviously that's too big. But if you cut it in half, you're going to get a number that's just right. Cut 400 in half, you get 200. And then cut 40 in half, you get 20. So 44 times 5 would be 220. That's going to be perfect for us because if I go up one more to 6, I'm going to go over 250, right? So this is the perfect amount that we need. So we're going to write here that the answer is 5. Multiply 5 times 44, again, that's 220. Subtract 250 minus 220 is 30. And then we'll put a 0 here so we can bring that down and continue our division. So 44 is going to go into 300 how many times? Well, 220 plus 44 is going to be 264. That is as close as I'm going to get to 300 without going over. So that's going to mean that we're going to have an answer of 6 there. 6 times 44, as I just said, is going to be 264. Now we're going to subtract. I'm going to borrow all the way from this 3 here. This will be 2. This will be 10, then 9. Then this will be 10. 10 minus 4 is 6. 9 minus 6 is 3. And then 2 minus 2 is 0. So now I'm going to put another 0 here and bring this down. And I'm going to have 360. So when I did 44 times 10, we saw that that was 440. So then times 9, I could just subtract 44. I'd be at 396. That's still too big because I'm trying to get to 360. If I take 44 more away, then I'm going to be just right. 9 is too big, but 8 is going to be just right. So I'll use 8. And then what is 8 times 44? Let's do that real quick. 44 times 8. 8 times 4 is 32. 2 down, carry the 3. 8 times 4 is 32. Plus 3 is 35. So 352. So we're going to write 352 here. And we're going to subtract. 360 minus 352 is 8. And we'll put a 0 here and bring that guy down. So what is 44 into 80? Well, it's only going to go in once. Right? It's only going to go in once. 1 times 44 is 44. 44. And we're going to subtract. So I'll borrow here. This is 7. This is 10. 10 minus 4 is 6. 7 minus 4 is 3. So I got 36. And when I bring down my 0, I'm going to have 360. So I can already see that there's a pattern forming. I had 360 already here. If I have it again here, it's just basically going to repeat. So in other words, the result there was 8. I know I'd get 8 again. Then I get 1, then 8, then 1, so on and so forth, right? 8 times 44 would give me 352 again. I'm basically repeating this part right here, right? If I subtract, I'm going to get 8. If I brought down another 0, I'd have 80, and I'd be at this step right here. Right, I'd be at that step right there. So at this point, we can go ahead and just answer, right? We know that the answer would be 0.5681, where the 81 would repeat forever. So I'm going to put a horizontal bar over the 8 and the 1, again, to show that those two digits are going to repeat forever. Okay, for the next one, we have a mixed number. And when you have a mixed number, basically what you're going to do is you're going to take your whole number part and just write that. So that's going to be the part that comes to the left of your decimal point. You can basically just write a decimal point after that, because after that decimal point, you're going to put what the fraction is converted into a decimal. Right? So you just kind of treat them as two different things for right now, and then you merge them together in the end. So what is 3/8, right, in decimal form? We're going to do 3 divided by 8. Put your decimal point down and bring it up into the answer. And I'll put a 0 after that decimal point. 8 goes into 30 3 times. 3 times 8 is 24. Subtracting, you would get 6. Put another 0 and bring that down. 8 goes into 60 7 times. 7 times 8 is 56. Subtracting, you would get 4. Put another 0 and bring that down. 8 will go into 40 exactly 5 times. 5 times 8 is 40. Subtracting, you get 0. So we get 0.375. 0.375. And basically, you just merge these two parts together. If I have 5 and 3/8, I basically have 5 point and then 375. So 5.375, right? This part right here is your part of a whole amount. And it's the same over here. After the decimal point, we're working with part of a whole amount, right? As a decimal fraction, that would be 375 over 1,000, right? 375 thousandths. All right, let's take a look at another mixed number. We have 1 and 2/9. So again, I'm just going to write this whole number part here, this 1. I'm going to put my decimal point down. And basically, after the decimal point, I'm going to have this part of a whole, right? This 2/9 expressed as a decimal, right? So 2 divided by 9. I'm going to put my decimal point here after the 2 and bring it up into the answer. Put a 0, and now we can start our division. 9 is going to go into 20 twice. 2 times 9 is 18. Subtracting, we get 2. Put another 0, bring that down. You can already see that this is going to be an infinitely repeating pattern, right? 9 goes into 20 twice. 2 times 9 is 18. Subtracting, you get 2, right? You'll keep getting this over and over, so you'll have this 2 repeating forever. So we can go ahead and stop and say that the part that comes after the decimal point here is just going to be a 2 with a horizontal bar over the 2 to say that it's going to repeat forever. So 1 and 2/9 is equal to 1.2, again, where the 2 repeats forever. All right, now let's take a look at an improper fraction. So with an improper fraction, again, I'm just going to divide the numerator by the denominator. So 31 divided by 20. The only difference is I don't need to put a decimal point out to start, right? I'm going to have to do it at some point in this problem, but I don't have to do it right away because my numerator is bigger now than my denominator. So 20 will not go into 3, but it will go into 31 once. 1 times 20 is 20. If I subtract, I'll get 11. Now I can put a decimal point there and bring it up into the answer. Put a 0 behind it and bring it down. 20 will go into 110 5 times. 5 times 20 is 100. Is, again, 100. Subtracting, we have 10. Go ahead and put another 0 and bring that down. 20 goes into 100 exactly 5 times. 5 times 20 is 100. Subtracting gets 0. This is 1.55. And if we were to write this as a mixed number, remember what we would do is just not continue the division, right? We would have had 31 divided by 20. This would go in once here. 1 times 20 is 20. We'd subtract and get 11. So really, we could also say this is equal to 1 and 11/20, right? All of these forms are the same. We have this as an improper fraction. We have this using a decimal. And then we also have it as a mixed number. All right, let's take a look at one final problem. We have 17/8. So again, all I'm going to do is I'm going to take 17 and I'm going to divide it by 8. So 8's not going to go into 1, but it will go into 17 twice. 2 times 8 is 16. Subtract and get 1. And in the past, we'd stop and say, okay, our mixed number is 2 and 1/8. But here we can continue. We can get a result using a decimal. So I'm going to take that decimal point and bring it up into the answer. Put a 0 here and bring this down. So 8 is going to go into 10 only once. 1 times 8 is 8. Subtract and get 2. We'll put a 0 here and bring this down. So 8 is going to go into 20 twice. 2 times 8 is 16. Subtract and get 4. Put a 0 here and bring this down. 8 is going to go into 40 exactly 5 times. 5 times 8 is 40. Subtract and get 0. So 2.125. 2.125. 17/8 is 2.125. Or again, we could have also written this as a mixed number as 2 and 1/8, right? All of these are the same. We have our improper fraction, we have it as a decimal, and then we have it as a mixed number. Hello and welcome to Pre-Algebra Lesson 45. In this video, we're going to learn about percents. So our lesson objectives for today, we just want to learn how to convert a decimal to a percent and vice versa, meaning we also want to learn how to take a percent and convert it into a decimal. And then we want to learn how to convert a fraction to a percent as well. So a percent is just another method used to describe a part of a whole amount. Basically, it's just another fraction. So a percent is a fraction whose denominator is 100. Okay? So if you see a fraction and the denominator is 100, you're dealing with a percent. So as a more convenient way to write a fraction with a denominator of 100, we can use this percentage symbol to denote a percent. And I'll show you how to do that in a second. But one thing you need to understand is that the literal meaning is parts per 100. All right, so let's start out by looking at kind of the easier scenario. So let's say you start off on your test, you're having a percent test, and you have this 17 over 100. And your teacher says, write this using a percentage symbol. Well, the first thing you'd want to do is take your numerator, which is 17, and just write it. And then all you have to do is follow it with that percentage symbol. So 17 over 100 is equal to 17%. And that's all you need to do when your denominator is 100. It's nice and clean and simple. You have 17 parts out of 100 parts. Kind of something you can relate this to. Let's say that you take a test and you fail the test badly, right? You just completely bomb it. So you have 100 questions on this test and you only get 17 of them correct. So out of 100 questions, I got 17 correct. So my score on the test is going to be 17 out of 100 or 17%. Let's take a look at 3 over 100. So again, if the denominator is 100, to write this using a percentage symbol, I'll just take that numerator, which is 3, and I'll follow it with a percentage symbol. So 3 over 100 is equal to 3%. As another example, I have 96 over 100. Again, as long as the denominator is 100, I just write the numerator, whatever it is, in this case it's 96, and I follow it with a percentage symbol. So 96 over 100 is equal to 96%. Now we're looking at 512 over 100. And it's okay that this number is greater than 100. It doesn't matter. We're still just going to take the numerator, which in this case is 512, and we're going to follow it up with a percentage symbol. So 512 over 100 is equal to 512%. Okay, what about 0.01 over 100? Again, it's the same thing. I take my numerator, which in this case is 0.01, and I just follow it up with a percentage symbol. So 0.01 over 100, again, the denominator is 100, is equal to 0.01%. All right, let's take a look at something a little bit more challenging. Still going to be pretty easy, though. So we're looking at decimal to percent, right? So I'm taking a decimal, and I'm going to change it to a percentage. So to write a decimal as a percent, we just move our decimal point 2 places to the right and place the percentage symbol at the end. Let's look at this quick exercise. Change each decimal to a percent. So as I said, we're just going to move our decimal point 2 places to the right, and then we're going to put a percentage symbol at the end. So we're going to start out with 0.032. So I'm going to say this is equal to, I'm going to move this guy 2 places to the right, so that would give me 3.2, and I'm going to put that percentage symbol after it. So 0.032 is equal to 3.2%. Now, some of you might be saying, where did those zeros to the left of the 3 go? Remember, if I have 2 zeros to the left of the 3, that does not add value to the number, so we can just get rid of them. All right, for the next one, we have 0.115. And again, all I want to do is take this decimal point and move it 2 places to the right. So I ended up with 11.5, and then I put my percentage symbol after it. So 0.115 is equal to 11.5%. Next, we're looking at 6.23. Again, move the decimal point 2 places to the right. So that's going to be 623. And then put a percentage symbol at the end. So 6.23 is equal to 623%. All right, now we're looking at 0.85. Again, take your decimal point and go 2 places to the right. So I'd have 85, and then put the percentage at the end. So 85%. 0.85 is equal to 85%. All right, now we're looking at 0.00037. Again, this goes 2 places to the right. So this will be equal to 0.037 and then percent. And you can put it at 0 out in front if you want, just for clarity. Doesn't really matter. 0.00037 is equal to 0.037%. Okay, let's look at 2 more. We have 0.014. Again, this decimal point's going 2 places to the right. So that's going to be 1.4. And then just throw your percentage symbol at the end. So 0.014 is equal to 1.4%. And then for the final one, we have 312.25. Again, this decimal point goes 2 places to the right. So that's going to be 31,225. And then put your percentage symbol. So 312.25 is equal to 31,225%. Okay, so let's say we want to reverse this process and take a percent and go to a decimal. So essentially you just reverse what you just did. So to write a percent as a decimal, we move our decimal point 2 places to the left. Remember, we're going 2 places to the right. Now we're just reversing that and going 2 places to the left. And then we're just going to delete the percentage symbol, right? We're just reversing what we just did. So we're going to change each percent to a decimal. And I'm going to start out with 4.27%. So let me rewrite this over here. I'm going to delete this thing. I don't need it. And I'm just going to write the number 4.27. Now I'm going to need to add 1 0 in here to make this work. And this is going to go 1, 2 places to the left. So I'm going to have 0.0427, right? So 4.27% is equal to 0.0427, or I can put a 0 out in front for clarity. Again, 4.27% is equal to 0.0427. All right, for the next one, we have 39.867%. I'm just going to rewrite this number, 39.867. And again, I don't need this percentage symbol, so I can just leave it off. Now I'm going to move this decimal point 1, 2 places to the left. And so I'm going to end up with a decimal point there. Let me put a 0 out in front for clarity. And we'll say that 39.867% is equal to 0.39867. All right, for the next one, we have 215.37%. Again, I'm just going to rewrite this number, 215.37. I'm not going to write the percentage symbol. We don't need it. And I'm just going to move this decimal point again, 2 places to the left, 2 places to the left, and that'll go right there. So 215.37% is equal to 2.1537. Okay, for the last one we're going to look at, we have 0.003591%. And of course, I'm just going to rewrite the number. Leave the percentage symbol off. I don't need that anymore. And the decimal point is just going to go 2 places to the left. So 1 and then 2 places to the left. So that would be right there. And if I want to, I can put a 0. Let me kind of scoot this over a little bit. I can put a 0 out in front for clarity. So 0.003591% is equal to 0.00003591. All right, so now let's talk about the most tedious scenario you're going to come across. And basically, a more tedious situation comes up when we're asked to convert a fraction to a percent. There's kind of 2 ways you can think about doing this. The first way, let's say you have something like 4/5. Well, you could divide the numerator by the denominator, basically take the fraction and put it into a decimal, then take that decimal and convert it into a percentage. Now, the faster way would be to transform the fraction into an equivalent fraction with 100 as its denominator. But you're going to see that that's not always so simple. So for 4/5, let's do it both ways. The long way would be to say, okay, 4, divided by 5. Put my decimal point here and bring it up. And put a 0 here. 5 is not going to go into 4, but we'll go into 48 times. 8 times 5 is 40. Subtracting gets 0. So we know that 4/5 is equal to 0.8. And then to convert this to a percentage, we'd move this 2 places to the right. So 1, put a 0 there, 2. So the decimal point would go there. And then I would add a percentage symbol to the end. So 4/5 is equal to 0.8, and it's also equal to 80%. The other way you could have done this, which is much faster in this case, is to take 4/5 and just realize that if I multiply 5 times 20, I get to 100, right? And if you didn't know that, you could take 100 and just say, okay, if I divide 100 by 5, I get 20, so that means if I multiply 5 by 20, I get 100. It's whatever I need to multiply this by to get to 100. So if I multiply this by 20, my denominator is 100, and I know I have a percent. If I multiply the denominator by 20, I also have to multiply the numerator by 20 so that I have an equivalent fraction. So 4 times 20 is 80 over, again, 5 times 20, that's 100. So now I have a percent, a fraction whose denominator is 100. And when this occurs, we just simply take the numerator, which in this case is 80, and we follow it up with a percentage symbol. So we get the same answer either way, 80%. It's just a different kind of way to do it. And in most cases, this is going to be a lot quicker. But sometimes you're going to run into problems using this method. And I'll show you an example of that in a minute. All right, so what about 3/4? again, there's two ways we can kind of do this. We can take 3 and we can divide it by 4. Put my decimal point here and bring it up into the answer. 4 is not going to go into 3, but we'll go into 37 times. 7 times 4 is 28. Subtract and get 2. Bring down a 0. 4 goes into 20 exactly 5 times. 5 times 4 is 20. Subtract and get 0. So 3/4 is 0.75. 0.75. Now, again, to turn this into a percentage, I just move that decimal point 2 places to the right. So it's going to go 2 places to the right. That gives me 75. And then I just add my percentage symbol in. So 3/4 is equal to 0.75, and it's equal to 75%. Now, kind of, again, the quicker way to do this would have been to say, okay, I have 3/4, and I can multiply 4 times what to get to 100? Well, if you don't know the answer to that is 25, again, take 100 and divide by 4. 100 divided by 4 is 25, so therefore 4 times 25 is 100. You can always use little tricks like that to get what you're looking for. So we would multiply by 25 over 25, since that would give me a denominator of 100. And 3 times 25 is 75. So now I have a percent, right? I have a fraction whose denominator is 100. And essentially all I need to do is take that numerator and rewrite it, follow it up with a percentage symbol. So 3/4 is going to be equal to 75 over 100, and that's equal to 75%. Okay, what if we had 11 over 20? So again, we can take 11 and we can divide it by 20. So I'll need to put a decimal point here and bring it up into the answer. So 20 is not going to go into 1. It's not going to go into 11. It will go into 110 5 times. 5 times 20 is 100. Subtract and we'd have 10. Go ahead and put a 0 there and bring it down. 20 goes into 100 5 times. 5 times 20 is 100. Subtract and get 0. So 11 over 20, or 11/20ths, is going to be equal to 0.55 as a decimal. And then as a percentage, we just move this 2 places to the right. So that would be 55, put our percentage symbol, so 55%, right? So 11/20ths is equal to 0.55, which is equal to 55%. Now, again, kind of the quicker way to do this, I think everybody at this point knows that I can take 20, multiply it by 5 to get to 100. So I could have said, okay, 11 over 20. I can multiply this by 5 over 5. Again, I just need to figure out what I need to multiply the denominator by to get to 100. Right? And once I figure that out, I just do it to the numerator and denominator so that it's legal. 11 times 5 is 55. Over 20 times 5, that's 100. Again, now I have a percent. I have a fraction whose denominator is 100. So to write this as a percentage, just take the numerator, which is 55, follow it up with a percentage symbol. 11/20ths is equal to 55 over 100, which is 55%. Okay, let's look at one that's a little bit more challenging. So I have 23 over 46. Now, let's say I started out and I said, okay, what number can I multiply 46 by to get to 100? Well, it's not going to be a whole number. So that's where it kind of gets a little challenging, right? That's where you might want to save some time by just doing the division, right? You might want to say in this case, okay, well, 23 divided by 46. And a lot of you already know this is going to be 0.5, right? Because 23 is half of 46. But I'll put my decimal point here and bring it up into the answer. Put a 0 here. 46 is not going to go into 2. It's not going to go into 23. But it will go into 230 exactly 5 times. 5 times 46 is 230. Subtract and we get 0. So as a decimal, we would write this as 0.5. Now, to convert it to a percentage, again, we just take that decimal point and move it 2 places to the right. So it's going to be right there, and I can just get rid of it, right? 50 has a decimal point after the 0, but we don't need to write it. And then put a percentage symbol after the 0, so it's 50%, right? 23 over 46 is equal to 0.5. That's also equal to 50%. Now let's say that we wanted to go through and try to do it using the other method. So 23 over 46 times what over what will give me something over 100. So we know from basic rules that 46 times some number equals 100. 100 divided by some number will give me 46, or 100 divided by 46 would give me this number. So let me just go down to a scratch sheet here. So 100 divided by 46. What is that? Well, we can divide it out and kind of get a decimal, or we can keep it as a fraction. If we actually go through and get the division, we're going to get a number that we don't want to mess with, right? It's very, very messy. So let's just keep this as 100 over 46, and I'll show you how you can kind of use it this way. So let's go back up to the top and say that 46 times 100 over 46 would give me 100. And you can go ahead and check that. If we were to multiply these two together, this would cancel with this and just leave me with 100. So that does work. Now, if I do it to the denominator, I've also got to do it to the numerator. Now you see how complicated this has become. So I know that if I multiply 23 times 100 over 46, let's just do that problem down here. So 23 times 100 over 46. So I know that 46 divided by 23 is 2. So if I cancel this with this, I'm going to have a 2 here, and I have 100 up here. What is 100 divided by 2? That's going to be 50. So I can just cancel this with this and put a 50. So my numerator is going to be 50. Now in the denominator, as I just explained, this would cancel with this, right? 46 over 46 is 1, and I'd just be left with 100. So that's where I get that there. So I end up with 50 over 100, which again, as a percentage, is just 50%, right? I just take what's in the numerator and write it, follow with my percentage symbol. So you can see in this case, it's probably not quicker to go through and deal with all this. I probably could have just did the division faster, but it just kind of depends. I mean, it's fun to know both methods because in some cases it's quicker to do it this way, and in other cases it's quicker to do, the division and then convert that decimal into a percent, right? You just have to kind of know the situation.